All right, let's get this started. So this week we've got, as far as I could tell, two new PRs that came in. One is from Igor, looking at now switching the min-alloc size in BlueStore back to 4K for hard disks after his excellent work on the hybrid allocator and also his deferred big write PR. So that looks good. I think definitely we should switch it for master now and see what happens. Igor, I asked this in the PR, but do we have both the hybrid allocator and your big deferred write PR enabled by default now in master? I think you might be muted if you're responding.
Yeah, sorry, was on mute. So regarding big deferred writes, they are enabled by default, and I forgot to enable hybrid allocator in this new PR, so we'll do that shortly.
Okay, yeah, let's do that in master here. We can get lots of good testing in. That'll be exciting. All right. So the other new PR that I saw was one from me. This is just a request for comments, but I borrowed a scheme we did in FileStore a couple of years ago where the idea was that if we knew upfront how many objects we would have, we could pre-split the directories for PGs. And so this is a similar scheme in the MDS where if a user can hint that they're going to have a directory with lots of files, we can pre-fragment the directory and then avoid doing that while writes are happening. And that seems, at least in the testing that I did, to yield about a 2x performance gain for really big directories based on the test that I ran. So anyway, that's kind of exciting. We had a couple of PRs closed this week. Niha turned the balancer on in up map mode on by default. So we'll get some good testing on that in master here for the next release. Kifu added a PR for GitHub to add Jenkins tests for the classic OSD performance. So that's with all the stuff that they wrote for Crimson, but now also working with classic OSDs. So that's really exciting. Hopefully we'll be able to tweak that and maybe start catching big performance regressions. And then Igor, both of his PRs merged the hybrid allocator and also the deferred big writes PR. Updated this week. I think the NVMe device one here, Kifu's still working on a review for that. So no real movement, but just that he's going to do a review. This one from Majian Peng was updated with more numbers for changing the OSD opnum threads per shard to 1 for SSDs. We can talk about that more later here, in a bigger context with the shard upward queue. This buffer list iterator, use iterators for comparison operators. I think that got updated with some new code, but I haven't seen what exactly that is. Starting of the RocksDB database, Adam's excellent PR here. That I think passed its most recent round of testing, and it looked like Josh thought it looked good. So hopefully we can merge that soon. And then that will release a little bit of a logjam on a couple of other PRs that we want to get into the OSD. So that's exciting. Hopefully we can do that quickly here. And then Adam Emerson, it looks like maybe there were some new updates on your objection triumphant PR.
Just finished fighting with Shaman, so I could rerun a couple of the tests after a couple updates.
Okay, cool. All right, so that was basically it that I saw this week for updated and closed and new PRs. Was there anything I missed from anybody? All right, then moving on. So Majian Peng's thread shard testing that he did, we talked about this a little bit last week. To recap, he's basically seeing that with one thread per shard rather than two threads per shard and a high queue depth, the random read performance is significantly higher with one thread per shard. Um, and it was like between I think like 1.5 and 2x in a lot of cases. Um, when we spoke about this last week, I think we determined that this might not be good for recovery. Um, what I'm wondering is, okay, rather than switching from two threads per shard to one thread per shard, can we figure out what is actually going on here and what we're contending on? Um, so I asked Majin Peng for if he could just run some wall clock traces in both cases. We'll see if that can happen. Um, Josh, or for anyone that remembers, when we were writing the shard up work queue, did we ever do any testing looking at this kind of stuff?
We talked about this a little bit last week. I don't remember if we did specific testing at that point, but I know at later points in time it has been occasionally useful to have multiple threads per shard to let the OSD handle some kind of background work like recovery or backfill at the same time as client operations for the
Yeah,
same PG.
yeah. So I'm not sure it's a good idea to drop it down to one thread per shard. I'm just wondering if we could figure out like what exactly this is, if we're contending on locks or if there's something else going on.
Yeah, I mean, my guess would be some kind of locks like the PG lock, for example, but it's hard to say without the profiles.
Yeah.
And when this was written,
I,
the code was so different at that point, I think the results wouldn't really be comparable to today.
okay. I do remember when I've done some wall clock profiling that the sharded upward queue has looked suspicious. You know, I see it popping up with, I think it maybe was PG lock contention, um, specifically in the random read case, I think. So maybe this, it wasn't huge, but maybe that was like a, canary in the coal mine, right? Like there's something going on there. Um,
Well, I mean, if there is contention in the workload, that's where it shows up. So it's not surprising if it pops up. Like once things get
yeah,
into a PG, they're serialized and ordered, but the way they get serialized and ordered is the sharded op work queue mediates that. Um, so we expect it to be a point where things get blocked. That's
does
kind
it
of its
make,
purpose.
Greg, does it make sense though that with two threads per shard and 8 shards, he would be seeing significantly worse performance than with 16 shards and one thread per shard?
I mean, maybe. I mean, like if you have 16 shards, then you know that none of those shards will contend, and if the workload is evenly split, like all the way even, then yes,
Sure, sure.
there will be no added contention points. Um, I think I haven't looked at the data you've gathered. I think the reason that we do multiple shard or multiple threads per shard is because in a read workload you use up some of those threads can block on the read while the read's happening. Those all happen in line instead of on waiters,
I thought it was
and so we don't want.
the case. Oh, go ahead.
Well, we use up a work queue thread while performing a read, and so we want to allow other reads to happen in that at the same time. It could be that isn't right in terms of our assessment of the impact, but that's my recollection about why.
I mean, maybe we should be asking Ma Jianping what he sees if he does 16 shards and one thread per shard, and 16 shards if he does two threads per shard. So I think he was trying to look at like a total number of threads, either in 8x2 or 16x1 configuration. But maybe this just is telling us that we just need more shards, right? I think 16 is actually the default, so maybe, or maybe we'll
Yeah,
see.
maybe.
Because if that's the case, right, like adding more threads per shard doesn't do anything if you're contending on the PK
Well,
lock,
yeah,
right?
and it
So
looks like this test is just against one OSD in the cluster. And so he's
mhm,
changing the queue depth, but that's gonna be, I'm not sure that that's accurate for any larger
yeah.
system. Um, it may be, but yeah.
I think I'll
I don't
ask
think
him
these
to look
numbers,
at,
I don't think these numbers are actually useful for anything else.
yeah. I think I
'Cause-
agree with you.
yeah.
Okay. I'll maybe reply in there and just ask for just maybe for completeness if you can do like 16 and 2 and 16 and 1, see if there's any difference. But I think you're probably right that in a larger context of a bigger cluster, this is probably going to be less important.
It also can help
Okay.
to try a more realistic workload rather than pure random reads. Like typically you have reads and writes mixed together, and that's where like the contention that Greg was talking about in terms of synchronous reads might come into play more as well.
Sure.
So if you have one read blocking a thread, then you don't have the ability to schedule more writes asynchronously at the same time.
Yeah. Yeah. Okay. Let's see. Moving on. Igor's hybrid allocator and big deferred PRs merged, so time to enable 4K min size for hard drives. I think that's absolutely right. Anyone have objections or other thoughts? All right, Igor, as soon as you get that other change to make the hybrid allocator default, then
Already,
I'll go ahead
already
and.
there.
Oh, fantastic. I will approve that then. Sounds good. Okay, and then performance CI. Kifu, you did a bunch of work, or at least some work. I don't know how much it was, but it looks like we can do classic OSD tests now.
Yes, we can trigger it using the trigger phase or just label a PR with the performance. That will do the trick.
Oh, fantastic. So that works as well. That's great. All right. Kifu, I saw that you had run it on a PR that I looked at, and I don't remember which PR it was, but I saw that it failed because the standard deviation was too high.
Yes, one out of 16 acceptance criteria was not accepted, so it's kind of okay-ish. That one was from Casey. That's PR, I mean.
Yeah, that's right. Yeah. Do you think we need to make the range bigger?
I agree. I think.
Okay,
You make it
cool.
the call. You're the boss in this area.
No. Well, I'll say it's sloppy. So I think we could probably just say 50%, and then if we have major performance regression, it's better than nothing to know. But for small ones, I don't think this will ever give us really fine-grained data. Maybe if we're really lucky, but it's
Yes.
difficult to consistently get real
But
accurate.
it's still weird because only a single test is allowed to run a single box. So then there should nothing to interfere with the performance. In this perspective,
Yeah.
it should be consistent. The test result should be stable. I mean,
One thing I've noticed over the years is that sometimes the longer the kernel runs for, the worse our performance gets. We may have to reboot the machines every day.
okay.
I was going to
I
ask you, Kifu, did
I will adjust
did you?
the acceptance criteria and add you as a reviewer anyway. We increase it to 15%.
Sure. Kifu, I was going to ask you, have you seen, are we using the other Inserta nodes yet? The ones that we added to the pool?
Yes, I think so. We have like 4 of them, if I recall correctly.
Yeah, yeah. How long does it take to run the test?
22 minutes to 30 minutes.
Okay. So we can do about 8 to 12 tests per hour now. I wonder how many PRs we get per hour on average.
No more than 2 on average, I guess.
So we could maybe even run this test on every single PR.
I think so.
Cool. Well, thank you for doing that. That's really exciting. Josh, anything that you want to more talk about with Performance CI this week?
Let's see. I think nothing is too particular. I guess maybe some of the next steps we talked about last week, like respect to trying to make a common database schema for different benchmark results.
Mm.
I'm not sure if you've had time to think about that, Mark or Sridhar.
Yeah, I have not. Sridhar, have you had time to look at that at all?
Sorry, I was muted. So yeah, I haven't had a chance to look at it, Mark and Josh. So probably the coming week or so, I'll try to spend time on it.
Okay. Yeah, just feel free to reach out, email me or whatever when you have time, and yeah, I can try to help out if necessary or if you'd like it.
Sure. What I plan to do is run some basic tests with the sample data that we have and come up with a simple schema maybe, and then we can take it up from there. Does that sound good?
Yeah, sure. Go ahead. That sounds fine.
Okay. Yeah.
Cool. I see a couple comments in here. Back to English. All right. All right. Well, I think that's it, guys. Anything else, or should we finish up early? All right. Well, then, have a good week, everyone, and we'll see you next week. Thanks.
See you next week.
Thanks.
Thanks. Bye.
Bye.
Thanks.